What's up, everyone? We're here in section 9.4, and we're going to take a closer look at how common logarithms can be used to solve exponential equations. Okay, we've already discussed common logarithms a bit. Recall, these are logs that have a base of 10, and often the base of 10 is not written, right? Log base 10 of x is the same as just log x. It's understood when you see no base to be a base of 10. And the nice thing about common logarithms is that our calculators have a log button on them that it represents a common logarithm. So that means our calculators can be used to evaluate these types of logarithms, all right? So let's evaluate each of these on a calculator to 4 decimal places. You can use a scientific calculator, a graphing calculator, or I'm actually going to use Desmos. It's got a scientific calculator app. Okay. All right. So here, to get the log feature, I have to hit function, and then you're just looking for log, and then we just want to punch in 6. Okay. Now, before I do that, think about what this is asking. Log 6 means 10 to what power is 6? It's got to be a number smaller than 1. Okay, approximately 0.7782. All right. Next, we've got log of 0.35. So 10 raised to what power is 0.35? Since that's smaller than 1, that tells me my result has to be a negative value. Okay. Log of 0.35, negative 0.4559. All right, and then how about common log of negative 2.1? Right. 10 raised to what power is negative 2.1? I'm getting an undefined value, or some calculators will just say error. And the reason for this, recall, you cannot take the logarithm of a negative number. If I take 10 and I raise it to a power, no matter what that power is, whether it's positive or negative, the result will never be able to equal a negative value of negative 2.1. Okay? All right, so moving forward, now let's see how we can use common logarithms in our calculators to solve some exponential equations. Okay, we have a property of equality number 2 for logarithmic functions. It says that if m equals n, then log base a of m equals log base a of n. So this is essentially the first property of equality in reverse, okay? And what's nice about this property is it's basically stating that we can use a logarithm as an operation to solve equations, okay? This is huge. It is very useful in helping us to solve exponential equations where both sides of the equation cannot be written in terms of the same base, right? So let's say we're trying to solve 6 to the power of x equals 42. I am unable to write 6 and 42 in terms of the same base, okay? So here's going to be my approach now. I'm going to take the common logarithm of both sides of this equation. And that helps me because I can now apply a power property of logarithms. I can bring x out in front to multiply common log of 6. Okay, and what you really have to understand here is that common log of 6, it's a numerical value that's multiplying x. So just like any other numerical value, you can divide both sides by it. Okay, and now you let your calculator do the work for you. All right, so I take common log of 42. Make sure you close out that first parenthesis and then divide it by common log of 6. And we're winding up with 2.0860, which seems reasonable, right? 6 raised to that value equals 42, and I can, of course, check that. 6, let's start anew. 6 raised to the power of that value, exactly 42. All right, now let's get a more sophisticated equation. 3 to the power of 2x plus 1 equals 6. I'm unable to write 3 and 6 in terms of the same base here, so I'm going to begin with the same approach as the last problem. I take the common log of both sides, and now I apply a power property. This time, since the power is a binomial, I'm going to put it in parentheses. Okay, and then remember, once again, common log of 3, that's a numerical value, so I'm able to distribute it into that binomial, and I'm just going to write this as 2x log 3 plus log 3 equals log 6. Okay, now the whole goal here is to solve for x, right? Well, I have two constants in this equation right now. I have log 3 and log 6 that are both constants. So I want to get those to the same side, away from the variable. So I'll subtract log 3 from both sides here. And I'm just going to write this now as 2x log 3 equals log 6 minus log 3. Okay. And then to get x alone, I can simply divide both sides by 2 log 3. 2's wipe out here, so the common log of 3, and now it's calculator work. Okay. You have to be very careful when you type this in, however. Make sure if you're going to put it in all at once, please put parentheses around the numerator and around the denominator to make sure that order of operations are being followed, okay? So we'll start with a parenthesis, log of 6. Make sure you close out log 6, subtracted by log of 3. Close out log 3, then close out your numerator, and now that's divided by parenthesis 2 log 3. And we're winding up with 0.3155. Okay. Now understand, rather than typing all of that in, you technically could use a couple properties associated with logarithms. Isn't log 6 minus log 3, isn't that the same as common log of 2? Right? Because you can use a quotient property and take 6 and divide it by 3. And then isn't 2 log 3 the same as log 9? Because you can apply a power property there. So let's just double check. Is that log 2 over log 9 going to give us the same result? Log 2 divided by log 9. Absolutely. Okay, so it's just a matter of preference on how you want to go about before you input into your calculator. All right. Okay, now it's your turn. You're going to move to practice 1. Try that problem yourself. It's very similar to this example, so if you get stuck, come back and watch this video example one more time before you try.